Unit 6, Polygons in Motion. Preview video 6.3, Rectangles and Rhombi and Squares. Oh my! You can tell me what that is a reference to when you get to class. Sit tall. Ready? Deep inhale. Hold your breath. And exhale. So taking a look here, don't forget date, time, location. And we are right here. As a quick review, what is a parallelogram? OCD, opposite, 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 consecutive, diagonal. You need this review. Let's do this now. So the first one is opposite sides are parallel, because that's the definition of a parallelogram. Then opposite sides are also congruent in length. Opposite angles are congruent. Consecutive angles are supplementary. Consecutive means the angles that are next to each other are going to add up to 180 because they are consecutive interior angles with parallel lines. Last one is if you draw in the diagonals, they do not bisect the corners, but they bisect each other. The diagonals bisect each other. In other words, it's the midpoint going both ways. That's the definition of OCD. The reason why is because rectangle, rhombi, and squares all qualify as a parallelogram. They're just a special type of parallelogram. So right here, the definition of a rectangle is if you have a parallelogram, kind of put your hands like a parallelogram, and then you take and you square up the corners into a right angles, it's a rectangle. So a rectangle is a parallelogram with 4 right angles. So if you take a parallelogram and you square up the corners, you have a rectangle. So a rectangle, by basic definition, is a parallelogram with 4 right angles. What is a rhombus? Again, if you start with a parallelogram like this, so you have 2 congruent sides and 2 longer congruent sides, if you short it up so that all 4 sides are equal, then it becomes a rhombus. All 4 sides are equal, then it becomes a rhombus. Therefore, a rhombus is a parallelogram with 4 congruent sides. Quick review, A rectangle is a parallelogram with 4 right angles. A rhombus is a parallelogram with 4 equal sides. So when I have a parallelogram, for a rectangle, you have 4 right angles. For a rhombus, you have 4 equal sides. So both shapes are parallelograms. So they have all the qualities of a parallelogram, which are the OCD qualities. We're not going to repeat those. But in addition, they have 2 additional characteristics each. In a rectangle, what makes a rectangle unique is you have 4 right angle corners. 4 right angle corners. That's kind of the definition of a rectangle. And if you trace this diagonal, the red, this diagonal, the green, I'd like you to finger pinch the red and then hold it, swing it around, finger pinch the green, red, green. What you should notice is that the diagonal lengths are actually congruent. So the red and green are congruent in length to each other. And if that's the case, and that's the midpoint because it's a parallelogram as well, that means all 4 of these pieces are congruent. Couple things to watch out for in a rectangle. 1, because of those 4 equal pieces, you have 4 isosceles triangles. That's going to come into play. And also, watch out, in a rectangle, you always have 2 giant right triangles. In a rhombus, what makes a rhombus unique? 1, you have 4 congruent sides. And not only that, the diagonals are not equal lengths. One's longer than the other, but the diagonals are perpendicular to each other. The diagonals are perpendicular, which creates a right angle in the middle. And the diagonals also bisect the corners. Notice the hatch marks, equal that way, equal this way. Bisect. So the last one here, the diagonals bisect the corners. You need to memorize all these qualities. They're going to come into play. So here's your quad family tree. This is what we're ultimately shooting for. So here you have a parallelogram. And both a rectangle and a rhombus qualify as a parallelogram. A rectangle is a parallelogram with 4 right angles. A rhombus is a parallelogram with 4 congruent sides. So a rectangle and a rhombus get married, they have a kid, and the kid is a square, which means you have 4 right angles and 4 congruent sides. So a square has all the qualities of both a rhombus and a rectangle. So now, using these qualities, we are going to do a couple problems together. Put your finger on your paper right here. You're going to read with your lips moving. Kids, ready? Read. In a rectangle below, trace and mark the given information on the diagram. Then find all possible angles and sides. Remember, this is a rectangle. Get in the habit, the minute you are told what shape it is, start marking everything you know to be true. What makes a rectangle a rectangle? 4 right angles. What else do we know is true? That's a midpoint. Diagonal lengths are equal, so all 4 of these pieces are equal. Those are some of the unique qualities of a rectangle. Now we're going to E to I is 2x plus 1, and F to H, the blue, is 3x plus 10. And then the last is angle IFG. IFG, this angle right here, is 51 degrees. We want to find everything possible. Let's start with our variables. You ask yourself, what is the relationship between the blue and the red? And what you should notice is that 2 reds, 2 EIs, make 1 blue, FH. Things before algebra. So we have 2x plus 1 equals, circle plug chug, right there, 3x plus 10. Why don't you keep your nose down, do your own algebra, and look up in about 20 seconds. See if you get the same thing as me. Try to do your algebra on your own, folks. Now, once you've solved for x, we're going to plug it in and see if it actually works. So we're saying x is 8. Well, let's see if it works. 2 times 8, 16 plus 1 is 17. So that means this is 17. And then here, 3 times 8 is 24, plus 10 is 34. So this entire thing is 34. And it takes 2 17s to get into 34, so you know you're right. Let's go ahead, and we're trying to find all segment lengths and angles. So remember I told you to watch out for isosceles triangles here. So we have an isosceles triangle. 2 equal sides, 2 equal angles. So that's 51. And we can go like this as well. Armpits of the Z. Which means this is 51 degrees. This is 51 degrees. And because of the 90, I can do 90 minus 51. And of course we get 49 here. 49 there as well, because 2 equal sides, 2 equal angles. 2 equal sides, 2 equal angles. Why did I bring it down there? Well, once again, we have armpits of the Z going on there. How do I get these angles in the middle? I can add 51 and 51. Take it away from 180. That's going to be 102, which makes this 72, this 72, this 102, and 102. You think you're done, but wait, there's more. You think you're done, but wait, there's more. I asked you to find all segment lengths. So take a look here, friends. We can now work the side lengths in this right triangle, which we are going to do. And we are going to find this outer side length that we're going to call that short one X and this long one Y. There's so much information just because you have a right triangle. I'm going to pull this out. We have X and Y. Now, we can work with 51 or 49. It doesn't matter which one. You can totally choose. I'm just going to pull the 49 just for giggles. And you have to choose one because now we label from that angle. We label our opposite, our adjacent, and our hypo. And our hypo, we already have, is 34. So we're going to go for X. For X, I have the hypo. I need the opposite, which means I'm going to do sine because I have OH. So I'm going to go So I'm dealing with an O and an H, and so that's going to be sine of 49 degrees, opposite. Our opposite is X, and our hypo is 34. I'm going to set both of them up so it's easy here. And then our Y, our have, we have the hypo, we need the adjacent for the Y, and for that one, it's A, so we're going to do cosine 49 over 1 equals adjacent, which is Y, over hypo, which is 34. We cross multiply for both. So we're going to get X is going to be sine 49 times 34. And Y, if you cross multiply, is going to be cosine 49 times 34. You thought you were going to get away from SOHCAHTOA. You were mistaken. You thought you were going to get away from all of that right triangle stuff just because we're in the next unit. You were mistaken, my friends. So you can check your own calculator and we can double check your answers. So the first one I'm going to do sine of 49 times 34. And I get 25.66. I'm going to round to the tenths. So it's going to be 25.7. And for Y, it's cosine 49 cosine times 34. And we are getting 22.3. So now you have all your side lengths, and obviously it's not drawn to scale, and that's totally okay. So we have here, this is going to be 25.7, 25.7, and this one right here, 22.3, and 22.3. Lots of information for a rectangle. Rhombus is a little easier. We have ourselves a rhombus here. And we are told that P2R is 10. The whole thing is 10. And Q2R is 13. And TQR, which is right here, is 23. Now, the minute you have a rhombus, you should instantly be marking everything you know to be true. Couple things, super important. By definition, a rhombus has 4 equal sides. A rhombus also has perpendicular diagonals, which means we've got right angles in the middle. We also have a midpoint going this way, and these angles are bisected. So we mark bisector, bisector, bisector this way, bisector this way. And you're being asked to find everything possible. We're going to do angles first because angles are a little bit easier to work with. So right here, if I have in this triangle right here, I have a 23 and a 90. I'm simply going to add to 23 and 90 and take it away from 180. And I get 67 here. Now, because the diagonals cut that in half, I can walk this 67 over here. And because I have another right triangle, this is 23 here, 23 here. Another right triangle makes this 67, 67. You have all right angles in the middle. Congratulations, you're done. Yay. We have 5 and 5 here. So the only thing you're left missing is this diagonal and this one. But if you look carefully, we have a 5 here, unknown with the right angle, and we have 13. Have 2 sides, need third side, thag. It's your superpower. So what do we have here? We have 2 sides, need a third side, thag. So this is going to be, I'm going to do it over here, x squared plus the other leg squared, 5 squared equals 13 squared. We have x squared equals 144. The opposite of squaring is square rooting. So our x here is going to be 12. So you come back up here, and we found our x is 12, which means our entire diagonal here is going to be 24. And then all sides are equal, so we don't have to do SOHCAHTOA here. If that's 13, that's 13, that's 13, That's 13. You found all the angles, you found all the segments, you found all the diagonals. You are good to go. Now this square is actually the easiest of all of them. You'll see why in just a moment. I'd like you to do the square on your own. I give you one thing. I tell you that this is 12. That's it. Find everything possible. You have a minute. Go. You can do it. There's more to it. What's true about a square? Okay, let's see how you did here. So this whole thing, you were told, is 12. Now you ask yourself, what's true about a square? Couple things. One, a square qualifies as a rectangle, so automatically you know you have 4 right angles. A square also qualifies as a rhombus, so you have 4 equal sides. Which means if I have 2 equal sides, I have 2 equal angles, which forces it to be a 45, 45, 90, leg, 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 root 2. So we've got 45, 45 here, 90, which means this has to be 45 because the diagonals bisect each other. This is 45, and if you were to go this way, this is also 45, also 45. So you got a mess of 45, 45, 90 triangles. If I come here, right here, I'm going to do just one 45, 45, 90. 45, 45, 90, leg, leg, the legs are equal, and the height is whatever the leg is times root 2. So this reads, you should have done, something times root 2 is 12. That something here is 6 root 2, 6 root 2, 6 root 2, and 6 root 2. And then this, if one little piece, I have a right angle here in the middle because it's also a rhombus. That's 6, that's 6. Diagonal lengths are equal because it's also a rectangle, 6 and 6. I want you to make note of what you overlooked, and make note of that, and then summarize this page.